JA. This 101-story titan standing 492 meters over the Marina skyline. The building Dubai nicknamed the Glass Obelisk, the one that held the title of highest residential penthouse on Earth. That Snort's skyscraper was already climbing into the clouds when engineers looked at the telemetry, saw something terrifying in the shifting sand, and realized the entire tower was structurally compromised. The problem wasn't just the $1.2 billion budget. Though the money nearly killed it too, the problem was the very earth beneath it. A massive, high-tech marvel built on reclaimed land that millions of onlookers saw as a triumph of modern engineering, while underneath, the foundation was silently losing its battle with the Persian Gulf. Construction halted. The design was torn open and reworked. What is the difference between solid bedrock and shifting desert sand? So, how does a luxury megatower become a multi-million-dollar engineering nightmare, forcing one of the tallest residential buildings in the world to literally stabilize its footing mid-construction? To understand it, you have to go back to a Dubai that was rewriting the rules of architecture. This is the Marina Sovereign Center, right on the edge of the Arabian Gulf. 101 stories, 492 meters of pure glass and steel, completed during the height of the construction boom. For a brief window, it could legitimately claim to be the ultimate crown jewel of luxury living. But to understand why this building exists, you have to understand the sheer speed at which Dubai was moving. Rewind to the massive expansion phase. The city was absorbing billions in foreign investment. This desert coastline was being transformed into a forest of glass towers almost overnight. The plan was to turn sand into a global hub, and at the center, a super-tall giant that would define the marina. Into this high-stakes environment stepped a team of elite international engineers and billionaire developers, aiming to push structural engineering past its absolute breaking point, GA. To build a 492-meter monument on the edge of the desert, you have to fight two brutal forces: the searing Arabian heat and the fluid nature of coastal sand. The timeline for the Marina Sovereign Center began with absolute optimism. Ground broke as money flooded into the Emirates. The blueprint called for an ultra-slender silhouette, a column of continuous glass reaching nearly half a kilometer into the sky. But right from the start, the engineering timeline ran into a wall of geological reality. Unlike cities built on solid granite, Dubai's coastal strip sits on layers of loose marine sediments, sand, and weak carbonate rock. To keep a 101-story tower from simply toppling into the Gulf, engineers had to drive a massive matrix of concrete friction piles deep into the earth. For the first 2 years, everything seemed on track. The foundation was set, and the concrete core began to climb. Then, the global economic freeze hit. Construction abruptly ground to a halt. For years, the exposed concrete skeleton sat completely dormant in the salt-heavy air. This pause created a hidden, catastrophic complication. When a new investment consortium finally bought out the project and ordered construction to resume, the world had changed. The race for luxury height had intensified, and the developers demanded an extra 30 meters of height to secure the record for the highest occupied residential floor. But the foundations were already buried and locked in place. They had been engineered to support the load of a lighter, shorter tower. Pushing it higher meant adding millions of tons of unintended weight. To solve this impossible puzzle, the developers flew in premier structural experts who realized they had to completely reinvent the building's skeleton mid-construction. The team executed a radical weight loss strategy. They replaced heavy concrete internal walls with an advanced, high-strength structural steel outrigger system. By utilizing these diagonal steel braces, they managed to shave nearly 12% off the building's projected mass, allowing the existing foundation piles to carry the taller tower. It was an engineering miracle executed on paper, but as the tower pushed past its 80th floor, the real world began to push back. The combination of extreme summer thermal expansion and subtle shifts in the water table threatened to derail the entire project. As the Marina Sovereign Center climbed past 400 meters, it ran headfirst into a phenomenon that plagues super-tall structures across the region: the brutal mechanics of extreme heat expansion and glass fatigue. During Dubai's peak summer months, ambient temperatures regularly cross 45 degrees Celsius, pushing the external glass and aluminum facade to an astonishing 80 degrees. At these extremes, materials don't just get hot. They physically expand. A tower this tall can actually grow or lean by several centimeters in a single afternoon, as the sun bakes one side while the other remains in the shade. This constant, daily warping put immense stress on the structural joints. Worse, the internal air conditioning systems had to pump freezing air 24/7 to keep the interior habitable. This created a massive, violent temperature differential between the scorching exterior glass and the icy interior skeleton. If the seals failed, moisture from the humid Gulf air would instantly penetrate the structure, causing devastating internal condensation and high-altitude leaks. Engineers noticed that the glass facade was showing signs of microscopic structural fatigue much earlier than anticipated. The structural parallels to previous engineering miscalculations were terrifying. If the thermal expansion wasn't managed, the immense pressure could shatter the custom-engineered double-glazed panels, raining heavy shards down onto the busy marina boardwalk below. The team had to install specialized dynamic joints that allowed the glass skin to slide and breathe independently of the rigid steel and concrete core. But as the structural team raced to secure the exterior, a completely different crisis was unfolding inside the tower. The pressure was mounting from the luxury real estate market itself. Investors who had poured millions into these sky-high residences were demanding progress reports, and rumors were beginning to leak out about the building's stability. The narrative of an unstoppable, flawless mega-project was fracturing, proving that when you build at this scale, the physics of the environment will always find the weakest link in your design. Behind the glistening glass facade and the bold engineering triumph lies a much quieter, human reality. A luxury skyscraper is ultimately built for people, and when a project of this magnitude experiences structural delays and design overhauls, the fallout ripples through the lives of everyone involved. Take the site engineers who spent grueling 12-hour shifts in the suffocating summer heat, monitoring the precise alignment of the structural steel outriggers. They knew that a deviation of just a few millimeters at the base would translate to a catastrophic lean of nearly half a meter at the summit. For months, the pressure was relentless. Every creak of the building's skeleton during a high-wind storm over the marina felt like a personal test of their calculations. Then there were the international investors, wealthy expatriates and global buyers who had wire-transferred millions of dollars based on glossy brochures promising an unparalleled life in the clouds. Instead of moving into the world's highest residential penthouse, they found themselves locked in years of legal limbo, watching a half-finished concrete spire sit silent in the desert air. When the doors finally opened, new challenges emerged. The extreme height created a bizarre microclimate inside the upper levels. Residents reported hearing the eerie, low-frequency whistle of the wind, cutting through the specialized pressure release vents. On days when the coastal fog rolled in from the Persian Gulf, the top 20 floors were completely swallowed by clouds, cutting off views of the Palm and leaving residents stranded in a silent, white void. Even more troubling were the intermittent plumbing and air pressure anomalies caused by the sheer vertical distance water and air had to be pumped. The luxury dream was spectacular, but it required an army of specialized technicians working behind the scenes 24/7, just to keep the building's artificial environment from collapsing under the weight of its own complexity. It proved that living at 492 meters is less like occupying a standard apartment, and more like living aboard an experimental spacecraft permanently anchored to the desert floor. Today, the Marina Sovereign Center stands as a glittering landmark on the Dubai skyline, a 492-meter testament to human ambition. But beneath the luxury finishes and spectacular views, the building remains a permanent monument to a quieter, more urgent truth. A super-tall skyscraper on reclaimed land is never truly finished battling the elements. The future risk is a continuous calculation. As the weight of the massive tower pushes down on the coastal shelf, engineers must constantly monitor the foundations for any signs of uneven settling or shifting sand. The Persian Gulf's salt-heavy humidity continues to test the dynamic joints and structural steel outriggers every single day. requiring an endless cycle of high-tech maintenance and monitoring. The tower survived a frozen budget, a total structural redesign mid-construction, and the brutal physics of extreme desert heat. It proved that, in the modern race for height, the engineering is often the predictable part. The true challenge is adapting a half-billion-ton structure to an environment that is constantly trying to reclaim it. As Dubai continues to push the boundaries of architecture with newer, even taller mega projects, the Sovereign Center serves as a vital blueprint for the future. It stands as a reminder that no matter how much glass, steel, and capital you pour into the sky, the ground beneath will always have the final vote. The architect set out to connect the desert sand to the heavens. What the world learned instead is that when you build a monument this high, the most critical victory isn't touching the clouds.